We're going to look at a second algebraic method today to solve quadratics, and that is the quadratic formula. Here is the overall process. You're going to want to make sure that your equation is in standard form equaling 0, which designates that we're solving for the roots. And then here's the introduction to a new formula called the quadratic formula. You don't need to have it memorized, you just need to be able to have it somewhere next to your work. And notice that it's made up of your A, B's, and C's, so you definitely need to know what your ABCs are in your standard form. And then you're going to simplify using PEMDAS, either round your values to the hundredths place or simple radical form. With the quadratic formula, we'll now be able to find imaginary and complex roots, which we were not able to get from the graph or through the factoring method. So today we will. Here's the first example we'll do together. X squared minus 12x equals 28 using the quadratic formula. So the very first step is to make sure that this is in standard form. So I am going to subtract the 28 over to the side where all the numbers are, equaling 0. And then I'm going to take a second here and make sure I highlight my ABCs. I've got A is 1, B is negative 12, C is negative 28. The signs are very important that you have correct. Step 2 is a substitution process into the formula itself. So it's going to say x equals, notice again we have a negative b. I don't know if you picked up on it there, but you've got negative b over 2a, which is very reminiscent to the whole xv thing, which that's on purpose because it's all related. So negative b means we're going to have to negate the 12, so we actually have a positive 12 when we substitute in there. Plus and minus is going to be where we get our two answers for x, because we're going to do an adding step at the end of the work and a subtracting step at the end of the work, and that will explain how we get two x values. And so square root, this is a negative 12 squared minus 4 times 1 times negative 28. See how I substituted all that with your A and C? The A and C goes right there. All over 2 times 1. So the very first thing that needs to get done when you simplify is under the radical. So you're going to do negative 12 squared, which is 144, becomes positive anytime you square a negative, minus 4 times 1 times negative 28 will actually add, because you'll have a negative times a negative. So that all comes out to 256. And then, of course, multiply your denominator 2 times 1. At this point now, we still need to figure out what the root of 256 is, and that's where sometimes you'll get a decimal value, or you have to simplify as a radical. So right now, this actually 256 is a perfect square, so we get 12 plus and minus 16 over 2. And at this point, once the radical is done, this is where it branches out into two separate little calculations. You have 12 plus 16 divided by 2 and 12 minus 16 divided by 2. And that will give you two separate answers for x, and those will be your roots. So just make sure that you always simplify the top before you divide, because you have to make this part smaller before you do the division. You get 28 over 2, which is 14, and 12 minus 16 is negative 4 over 2, which is negative 2. And then to write your solutions, you've got 14 comma 0, because that's your x value, and then your y is always 0, negative 2, 0. Here's another example. X squared minus 4x equals negative 13. Again, you have to get your equation or your function in standard form. This time we're adding 13 to the other side to equal 0. And then I'm going to identify my ABCs. A is 1, B is negative 4, C is positive 13. And then I start setting up my quadratic formula. X equals negative negative b, again gives you a positive 4, plus and minus, square root. B squared is negative 4 squared minus 4 times a is 1, c is 13, all over 2 times a is 1. So when you simplify in this problem the root, you'll have 16, take away whatever 4 times 13 is, you'll actually now get a negative value under the square root, which we know now is an imaginary value when we simplify. So in this step, we simplify the root. You'll get an I that comes out of the box. And the square root of 36 is 6. It's a perfect square as well, over 2. And then at this point is where it branches out into two answers for x, 4 plus 6i over 2 and 4 minus 6i over 2. And remember that these are not alike. You got a real and an imaginary, so don't get tricked into saying 10, because those don't add up at all. Same thing here. Technically we're pretty much done, but you can reduce because we're dividing by 2 here. 2 divides into both of these numbers. So if it is divisible, you should divide them and get 2 here and 3. And then same thing here. You can reduce those numbers. Reduce, divide, I don't know which term you want to use. So here for our roots, we have 2 plus 3i, comma 0, and we have 2 minus 3i, comma 0 for our roots, which are two imaginary roots because of the i's, and on the graph it would mean that we have the parabola not touching the x-axis. We can't read these off the graph, but through the quadratic formula we're able to calculate and find the actual imaginary values.